Reference versus value. Before moving on, we're going to take a brief moment to break down the concept of arguments and variables as references versus as values. If these aren't phrases you've heard before, don't worry. This is a topic we've hinted at before, but have avoided explaining in full detail because it wasn't essential to understand at that point. By now, though, you should have been introduced to the idea of OO programming, meaning that the differences between passing by reference and passing by value is no longer something we can really just gloss over. Thankfully, it doesn't take long to explain, but like many new ideas, it might seem a little bit hard to take in at first. That's okay. To be expected even, that's the entire point of learning a new skill. Not to grasp it instantly, but to gradually build up an understanding over a period of time until it feels like second nature. Just like the others, you can review this section as many times as you need to. So, let's get started. Passing by value. Take a look at this. What number do you think this program will print? We have some variable, y, that gets passed to a call of function foo. Foo takes that variable and adds 1 to it. As y starts with a value of 10 and then gets passed to foo, so then the program should terminate with y equals 11. On the other hand, knowing what we do know about how functions work, surely when foo is called, y's value is passed to x. X only exists in the scope of the function, and it's x that gets increased from 10 to 11, not y. What happens in foo stays in foo, and there's no return statement, so y itself never changes. So y is 10, right? Both are reasonable guesses, but surely it can only be one or the other. Let's run to see what actually happens. It's 10. The value of y stays at 10, even after it's passed to foo. If this wasn't what you were expecting, let's take a second to break it down. Variable y contains the number 10. When y is given as an argument to foo, it is that number, 10, which is passed into the body of the function and not the variable y itself. We call this passing by value, so called because it is the value and only the value which is given to the function. The inside of the function only sees the number 10. It doesn't know whether it got that from a variable, a literal number, some other expression, and it doesn't really care. 10 is 10, after all. This is because of how numbers are handled in the background by Python. Numbers are immutable. They never change. We can move from one number to another, but each number itself is fixed. Think of it this way. If we passed the value 10 directly, we wouldn't expect this code to somehow change the value of 10 so that 10 equals 11. That would be impossible. 10 is always 10, and 11 is always 11. Passing by reference. All that in mind, let's look at the following. Here we've defined a new but very simple class, which we've called numBox. See, numBox only has one property, which we've called num, which is defined at the constructor. Our function takes a numBox object and increases its number property by 1, just like foo in our last example. And it doesn't return anything, it's only modifying parameters. Knowing what we know, we expect the printed value to be 10. Our variable a is defined as a numBox object with a num of 10. A is then passed to a call of function bar. We expect that when bar receives that parameter as argument x, it treats it as a new object, a sort of copy of the original one, if you like. Only this copy gets changed, so the original stays the same, right? Except, no, surprise, it was a trick question. But why? Doesn't that contradict what we said in our first example? Well, this time things are different. Let's explain why. Remember we said that integers were passed by value because they were immutable. That is, they never change. 10 is always 10, 11 is always 11, and they always will be. Objects of any class, no matter how simple, are different. They are mutable. They are not constant. They can change. In fact, most of them are changing all the time. This means that when given as arguments, they are passed by name. That is, instead of an identical copy, Python actually shares the original with the function. Any changes it makes will affect the original object. The reason it's called passing by name is because what the function actually receives is a pointer to the original object, sort of like a name tag, which tells it where to find it. But why? Before diving into the nuts and bolts of why this works the way it does, let's recap, as well as give a handy sort of cheat sheet overview you can come back to. If a function takes an argument, that argument needs to be passed to it. For items that are passed by value, the function receives a copy of the original value, identical to it. It can change this copy, but the original stays the same. For items that are passed by name, the object is not copied across, but instead shared with the function. What that function receives is a pointer. If it changes this pointer, it changes the original object as well. In Python, the objects which are passed by value are the primitive data types: integers, floats, strings, and booleans. The objects that Python passes by name are, well, pretty much everything else. So lists, dictionaries, every other collection data type, and any class objects. So why does it do this? It's got everything to do with what we said earlier about data being either mutable or immutable. Numbers never change. When we add two numbers together, we're not changing either number, we're working out an entirely new one. The same goes for every other mathematical operator, as well as operations on strings and booleans. We can even see this in the syntax. When we increased x, we didn't change it, we completely replaced it. X now equals something different than it did before. The fact that the new value is based on the old one no longer matters. The old x is gone. But if x is an object and we change one of its properties, then it's different. X's .num property might have been swapped out, and it has been swapped out. X.num is a new number now, but the actual object, x, remains. We didn't redefine x, just one of its properties, potentially one of many. Summary. With this concept, we've taken our first real peek behind the curtain of how the computer actually handles things in memory. Understanding this kind of low-level logic isn't always essential, but it can be very useful. Passing by name versus value might seem kind of arbitrary now, but the more code we write, the more we'll see why having and understanding the distinction is so important, especially if we want to write programs with more complex data structures like our collections and classes.